Hello and good morning. My name is Andre Duran. I'm the project manager and water resources engineer for Triscuit Engineering. We'd like to present our progress on the Crown Point Business Development Project. So to give you guys a little bit of an overview, we are developing a mixed-use business park in Crown Point, Indiana. The park will be divided into one acre or larger lots and includes a closed-loop drinking water system, an urban road connecting Indiana Avenue to Maryville Road. The design will also include a 40,000 square foot building and water quality best management practices on one of the lots. I would now like to hand it off to my transportation engineer.
Okay, so I will be talking mostly about the design of our parking lot for our building on our parcel. Begin with the parking lot requirements for our first floor, which is a office building with 20,000 square feet. So you can see that falls under arrows off, but one space per 200 square feet of floor space, which gets us to 100 spaces for the first floor of our building. And for the second building, it is a residential apartment building with 10 units, and at 2.5 spaces a unit, that gets you to 25 spaces. So there's 125 required spaces for the lot. Obviously, the parking lot has to follow ADA requirements. So in our 125 spaces, that means that 5 ADA spaces at a minimum are required. Here's some requirements that go along with this. For the car accessible spaces, they would be 96 inches wide with a 60-inch aisle, and you can see that the aisle has to be on the same level. All that. Here's a diagram of an accessible space. See the 96 inches with a 60-inch aisle. So the requirements for the spaces themselves, we went with 45-degree angle parking spaces. So that means that with supporting two rows, the aisle has to be 14 feet, the width of the space is 9 feet, and the length of the space is 20 feet. And then here's the dimensions of this design. It comes out to about 14 feet along the full length of the space of 20 feet and 9 feet. And then here is the design for the parking lot. It comes to 140 total spaces. You can see the ADA spaces at the top left of the lot, and it is one-way aisles, so it goes around and then back around. And then that is a two-way serving aisle in front of the building. And now I would like to hand it over to my structural engineer.
Hello, my name is Christian Robinson, and I am the structural engineer for Triscuit Engineering. Today I'll be going over a recap of what we presented from our last meeting, as well as a recent floor plan model showing some of the changes to the design I had made, and as well as the future work that will be conducted. So from our previous meeting, we decided to go with the second alternative, which was our steel square-shaped structure, with the first floor being utilized as our office space, equipped with small offices, break rooms, as well as conference spaces, and then as well as these stairs and elevators in the four corners of the building. For the second floor, that was the residential space equipped with apartments, lounge spaces, fitness centers, and other amenities for the tenants. And then here is a recap of the framing for how we're going to have our beams and our columns set within the first and second floor. I do, again, want to point out one of the bigger changes that we've made since our previous design was removing the elevators and the stairs from the four corners of the building, and I'll be able to talk about that a bit later. Another thing that we also decided to change as well is, since that middle space is going to be an open shared office space, that will require a lot of columns in the middle of the structure without really any walls to hide them, so we decided to do our best to try to move those around and minimize the amount of columns that we have just in the middle of the open space. And then as before, when we used RS means to come up with our construction cost, we came to about $8.6 million, which is a somewhat accurate or inaccurate representation considering RS means did not have the ability to separate or you could only separate the floors by use, so I had to essentially make each floor its own building. So some factors were accounted for twice, such as excavations, roofing, and other things that technically wouldn't be counted twice in a two-story mixed-use facility building. So again, as mentioned before, one of the huge changes that we made was getting rid of the four corners being utilized as stairs or being utilized as elevators, and we decided to make that more centralized and actually share one wall. So the stairs and the elevator will be located in the center of the building, sharing one wall, as opposed to having them in the four corners. We also decided to use that space that was open to account for more offices, so we do have over 30 different office buildings on our first floor, and then for our second floor, we have the previously mentioned 10 two-bedroom unit spaces that are available for our tenants, as well as 4 other rooms that could potentially be used for apartment spaces as well, or used for other amenities, storage, NEP, any sort of other things that may be required to ensure our tenants have what they need on the second floor of the building. Using Reason Floor, I was able to develop a floor plan for the new design. As you can see, the middle is cut out for our bay for the elevator and the staircase. After conducting the results using Reason Floor, it gave me W12 14 beams for all the beams there. And then for our second floor, we had a bit of an issue with the Reason results. It did not provide me with a specific beam type. It actually just said wide flange. And I put my best efforts forward to try to address this issue, and I consulted with Professor Reich as well. We were unable to figure out exactly what is the issue with RESA, so that is something that we will have to conduct in the future, figuring out exactly what sort of beams are to be utilized. This also delayed our hand calculations as well, considering it is hard to conduct a calculation to see if your beams are accurate if it didn't actually give you beams in the first place. So that is something that we will be moving forward with in the future and trying to figure out how we can resolve this issue to ensure that our beam choices are not only correct, but having our loads accurate as well. And then here is a 3D rendering of the structure so far. So again, you can see the middle has been removed on that first floor for our deck. As far as our decking goes, we're considering using a metal decking for the first floor, or no, for the second floor, my apologies, for the roof, and potentially using a metal deck for the first floor, or maybe using a composite, considering the residence that would be on the second floor for our structure. And I would now consider go into our future work. So again, as mentioned before, future hand calculation evaluations will be conducted to ensure that every aspect of our loads and our beam choices and our column choices are accurate, as well as an itemized construction cost analysis that would be more accurate rather than the RS Williams one using just the square footage estimator. And then moving forward, once we do have everything previously set, we'll be able to go on to our RESA 3D modeling for analysis and further design. And I would now like to pass it on to our environmental engineer.
Hi, I'm Brianna. I'm the environmental engineer here at Triscuit Engineering, and today I'm going to walk you through my progress for this semester. So starting off, I'm going to give you a quick recap. So this is my pipe network layout. Just a reminder, the pipes along East Summit Street, North Indiana Avenue, and Merrillville Road are existing pipes from the city, though that's what I connected to in order to form the closed loop system. The red dots that you see up here are my fire hydrant placements, and I'm working with a design flow of 6 cubic feet per second. So starting off, I performed the Hardy Cross method. This is just showing you how I labeled each junction and each loop. So I performed the Hardy Cross method for 3 different pipe diameters, 8, 10, and 12 inches. Up here, I'm showing you my final iteration for the 8-inch pipe diameter. As you can see, I get the head loss and the flow direction in each of the pipe segments. You can see that some of the pipe names are different colors. That just indicates that these pipes are shared between 2 different loops. And then this figure just shows you a quick recap of the flow rate and the flow direction in each of the pipe segments. And from this information, I went ahead and I performed my hydraulic analysis using the Bernoulli's equation, which I provided for you up here. I rearranged that equation to suit my needs. Because I'm using a consistent pipe diameter throughout the entire system, I have eliminated the velocities. So the change in pressures occurs because of the change in elevation as well as the head loss. And what goes into this head loss is the head loss that I calculated in the Hardy-Cross method, as well as the transition losses. So here I'm showing you where I'm getting these transition losses from. At each major junction, I've placed a gate valve. This is so that I can isolate each segment, well, not I, but in case of maintenance or emergencies, as well as when two pipes come together that is not at a major junction, I have placed a fitting. As of now, I have a 45-degree elbow fitting with a transition loss coefficient of 0.4. This has potential to change depending on what angle those pipes are actually coming into each other, but as of now, I just use the 45-degree angle in order to get a pressure change. As you can see, junction G at the bottom here, I do not have a gate valve there. That's because there was an existing fire hydrant that I'm connecting to, so there will be a transition loss coming from that fire hydrant instead of a gate valve. So this is the summary of the pressures that I got. As you can see, junction G at the bottom here is our lowest pressure of the system at 37 psi. This does exceed the minimum pressure of 20 psi set by the City of Crown Point. So I will continue with the 8-inch pipe diameter because that's what these calculations were from. And then for future work, I do need to account for the head loss due to fire hydrants. I don't see this being too major of a change, so I assume I will be able to use the 8-inch pipe diameter. However, as I do the calculations, if I do need to move up to a 10-inch pipe diameter, I will do so. I also need to perform hydraulic modeling using InfoWorks, and then I also need to finish off my construction costs. So now I will move on to our water resources engineer.
So just a little recap of my scope is flood control generated by the 100-year storm event, achieved 80% total suspended solids and 70% total phosphorus load reduction, and infiltrate 1 inch of water from all impervious surfaces. So the overall site has a lot of design constraints, like required setbacks. You need to be 25 feet from all buildings, 20 feet from high voltage electric poles, and at least 1 right-of-way width from roads. Additional constraints is the seasonal high groundwater table. This limits my allowable pond depth and requires a larger basin footprint. So for detention A, it's broken between these 2 ponds connected by a horizontal pipe. There's a west of road and an east of road section. They have a combined volume of approximately 600,000 cubic feet, a ponding depth of 3 feet, freeboard of 1 foot, and the outflow is limited to 5.3 cubic feet per second. On the east of road section, this includes our emergency overflow weir and our pond outlet. Here's a closer look at the concrete horizontal pipe. It has a length of 220 feet with a 2-foot diameter. We chose to make it horizontal so these 2 ponds can share an equalized flow as needed. Detention B, similar, has a volume of approximately 130,000 cubic feet, pond depth of 3 feet, 1 foot freeboard, and the outflow is limited to 1.3 cubic feet per second. So for the outlets, we went with perforated risers on both ponds. So they would both be limited to lower than the maximum allowable outflow. So you can see basin A has 5.27 cubic feet per second, and basin B 1.23 cubic feet per second. The emergency overflow weir, we went with rectangular weir with the 1 foot of freeboard, that's the height of the weir, and the discharge the weir needs to be able to pass is 120% of the peak inflow from the 100-year storm. So for detention basin A, it came out to 48 feet to satisfy this and 11 for detention B. Level pool routing, we applied level pool routing to evaluate detention basin performance. We developed stage storage, stage discharge relationships, routed the inflow hydrograph to generate the outflow hydrograph, and evaluate the peak flow reduction and storage requirements. And water quality, I know this looks like a lot, but bear with me. So the tree boxes in the parking lot treat 20% of the water quality volume. They're 3 feet deep with an underdrain system. The underdrain is to convey water to the downstream rain gardens. and they provide approximately 60% total phosphorus removal. The tree boxes next to the parking lot treat 50% of the water quality volume. They're deeper in design to promote infiltration, and they provide 70 to 90% total phosphorus removal. There's 2 rain gardens included in this design. Combined, they treat 70% of the water quality volume. They capture tree runoff not treated by upstream practices, and they also provide 70 to 90% total phosphorus removal. And then the vegetated filter strip primarily is used as pretreatment for 1 downstream rain garden in this design. And then future work includes finishing my plan and profile views for BMPs and detention basins and generating cost estimates for construction. Any questions?
I've got some questions. I guess, Andrea, one for you. So I noticed like your 1 tree box treated some level of total phosphorus and another one was a different number. Is that based on like how much volume they're
That's
capturing?
based on
Or the fraction of the volume that they're capturing? Or?
the tree boxes in the parking lot have an under drain,
Mhm.
so they actually treat less total phosphorus than the ones without it.
Oh, because of infiltration?
Yes.
Okay. Okay. And then, Brianna, you said your demand flow was 6 CFS?
Yes.
Where is that in the system? Like where is that demand being taken out of the network?
Where it's going out of the network.
Yeah.
So I can put that down just like visually for you to see. I don't know exactly what junction it's exiting from. Is that what you're asking? Like
Yeah.
where exactly it's exiting from?
Yeah, because that's going to affect all the flows in all the lines, like where it is, right?
Yes.
So it had to be somewhere in your model, right?
Yes. So what I did in order to, so I got the 6 CFS through like the fully developed future development. And then I just used that in order to, I'm trying to okay, what I'm trying to say is I didn't follow the arrows, the direction of the flows that I do have, I didn't follow to see exactly where, at what junctions it is exiting the system. So I can get back to you on that, I can email you about that.
Okay.
And follow
Okay.
where they go.
Okay. And then do you know what a transition loss coefficient is for a fire hydrant?
So for the fire hydrants, there's minor losses and then there's major losses. So for the minor losses, I've been told by my advisor just to use what I would use for the wide open gate valve. So I think that's the 0.2 that I had up there. But then for the major losses, this is why I didn't have it done, because I was a little confused on the major losses for the fire hydrant. So I'm working on that.
Okay. Yeah, I don't know what it is, so I was
Yeah,
just curious.
it's a little, I have a document, but it's a little confusing.
So the minor losses and major losses, is it like one or the other, or is it both at one
It's
time?
both of them,
At one time?
yeah.
Okay. Yeah, for now.
Andre, maybe as an investor in the land in there, why did you decide to go with 2 detention ponds rather than maybe one pond and save on the land? So I'm looking at the big picture in there. So if you get an overall view layout, and so why don't you just have a catch basin to convey the stormwater to that like big square detention pond rather than having to consume more land that can be valuable?
Great question. I just think it's because of the, I wouldn't be able to fit. Most of this goes downstream towards this way anyways, so I would have to have water flow upstream for it to, come to this larger detention pond over here.
So why don't you put the big detention pond on the other? And so relatively speaking, how big is that in acre feet? That's how I can relate actually rather than cubic feet.
Well, I'm not sure at this moment how big it is. I can get back to you on that. But hindsight's 2020. If our site wasn't right here, I would have one large detention pond. But since our site is here and we have all these required setbacks, I'm unable to put one large detention pond down.
Well, I mean, just first look on the layout, it seems to be very large compared to the lot size, the amount of stormwater runoff that will be generated from that lot. So you're having two detention ponds. Actually, if you combine them side by side, they take most of the area.
Right. I was scared that I'd run into this seasonal high groundwater table, like I was saying earlier. I still need to be above that for my dry detention ponds.
Okay, so how deep is your pond?
It's 4 feet deep or it's 3 feet deep of ponding depth with the 1 foot freeboard, so a total of 4 feet.
Well, that's a lot.
Yeah.
I mean, you may want to check your flood control volume in this case. They seem to, I mean, that's a huge detention pond or ponds in this case. About the road in there, go back, I think you presented the parking lot. Can you tell us more about the road design you are doing?
Well, my road design hasn't changed much since the last progress report.
Unfortunately, I don't remember what it was.
What exactly are you asking?
I mean, I'm asking about the design of the road because you just presented to us more like the parking lot. I mean, is that what you spent the time so far in the semester?
Yes, the majority of the time has been spent on this parking lot. The road hasn't had any major changes to it since the last progress report, so I didn't include anything about it.
Thank you.
So as long as we're on this slide, how do you get in and out of the parking lot?
Okay, so the entrance is at the road. Is that what you're asking specifically?
Yeah.
Or
So I'm thinking about that vehicle that is going to use that handicap parking space. How does that get there?
so that is the probably most difficult part of this. So they would have to take. All right, so they would have to take a route like this to get to that spot. And I know that's not the most ideal way of doing it, but in order to get the ADA spots the closest possible to the building, and then also have an easy sidewalk that isn't shown on here, but easy access to the building, that's the best spot for them. So,
Yeah, I can see that's the best location. It's kind of the routing seems to be a bit
yeah,
cumbersome.
What's the red line? Is that the border of the property boundary? Okay.
I've toyed with other ways of doing it that include putting the ADA spaces down here, which presents its own problems and other things. But at the moment, this is my ideal location for them. It just takes a little bit of an extra route to get to it.
I was wondering, so would they have to drive all the way up to that top row? Essentially, they wouldn't be able to turn right because is that too close from that second row down from the top
What are you
to
saying?
drive on the right side of it?
What are you saying? Oh, I mean,
So yeah, if you
like,
turn
do
right,
this, is that what you're saying?
if you turn right at the entrance, right, you turn right here and you go directly up straight. So turn right all the way down. Like
She's talking about that second island. It looks like it's really close to the edge of the
yes,
parking lot.
that's
so
what I'm
she's-
saying. That second row down, it looks like it's really close to the red line.
Here?
Would they be able to go straight
One
up
up
from there?
So,
Right there, like if they were to come through.
The one that
I
has two
see,
trees in it.
right here.
Yeah, I understand.
Yeah, would they be able to go straight right here?
I
Is that
mean,
too close?
this is to avoid people ending up going the wrong direction. It could be, I could change it so that it's not included and cut some more parking spaces off to allow for some through access. But I think, in my opinion, this blocking island just prevented some issues with flow of traffic in the parking lot.
Okay.
Any more questions?
Okay, good, thanks.